Math 102, example 3.2.4 version B. Now we do have two theorems that we need to discuss in this section. The first is the remainder theorem. And this says if I take my polynomial function p of x and divide it by x minus k, the remainder is the same thing I would get if I evaluated p of k. So if I have my polynomial, p of x is x cubed minus 4x squared plus 9x minus 10, and I want to find p of 3, that means I take that and divide it by x minus 3. Now as I set up my synthetic division though, I take the opposite of the number with the x in the divisor. So I still put a positive 3 there. If you've got an x in front of the number, that's when we flip the sign. However, if you've got the number by itself, like we do here, then we do actually just leave it as is. All right, let's do our synthetic and see what we get. 3 times 1 is 3, plus negative 4 is negative 1, times 3 is negative 3, plus 9 is negative 27, times 3 is negative 81, plus negative 10 is negative 91. Now our other theorem in this section is the factor theorem. The formal theorem says that the polynomial function p of x has a factor of x minus k if and only if p of k equals 0. I'm going to rephrase that to make it a little easier to understand for this class. So if I take that function p and divide it by x minus k and get a remainder of 0, that means that k is a 0 of that polynomial. Now here, my remainder, needless to say, is not 0. That's definitely not 0. So here, 3 is not a 0 of this function p. Right now, I don't know what is. We'll start looking at that in our next two sections. All we know is 3 definitely doesn't work.